So we are going to continue chapter 8 by starting off with section 8.8. It's factoring by grouping. The reason we do this one first is because it requires the steps that lead into the others, even though they listed as 8.8. So we will be doing that last section first. I'm not going to put a notes number or assignment number because I'm recording this ahead of time. You'll have to get that off the information on the Remind or in class off the sheet, but let's go ahead and get started. So we are going to be dealing with factoring, and we already talked about factoring out of GCF. So when we start a problem when we're factoring, we need to make sure that we go through and we factor out anything that's common to all four terms to start off with. We look for a GCF for all of them. When you look at these, we've got 3x to the third, 12x squared, 2x, and 8. There's nothing common to all four of those terms, so the very first thing we're going to do is we're going to do what's called factor by grouping. We are going to group two things together so that we can factor out something in common. So we're going to group this first two pair together and this last two together. We're going to take a GCF out of these. For 3 and 12, they will both divide by 3. That will be the common number that goes into both of them. And then x is common to both of them, and we look for the highest power that will go into both of them. So there's a 2 and a 3. The highest thing that will go into both of them is the 2. So 2 goes right here. We pull that GCF out in front, that's 3x squared. And we simplify. That's going to be the 3's canceling out. Using our exponent rules, we divide this. X to the third divided by x to the second would leave me just x to the first, which is x minus 12 divided by 3 would give me 4. Oops, sorry. Let me explain why. We just put a parentheses there. And the x squares cancel out, so we close out our parentheses. We do the same thing for the other set of parentheses, the other grouped items. They have a number in common that is a 2. We put that 2 here. Since that 2 is a positive 2, when we write it, we write plus 2. And then our parentheses, we simplify this out. That leaves us x. We simplify 8 divided by 2, and that will leave us 4. And guys, this is the whole point. As you can see, we have a common factor right here. We have a common factor of x minus 4 and x minus 4. What that is going to allow us to do is take that common factor and factor it out just like we did before. Put that x minus 4 out in front. What's left over would go in the other parentheses. So we have this 3x squared left over. It's going to go right here. And the plus 2 is left over, so it's going to go right here. So now, if you notice, this is like what we had before when we had multiplying binomials. And this is two binomials multiplied by each other. That's what you're trying to factor it to get. So from there, that is our final answer. We don't multiply it back together, guys, because the whole point is to break it apart. And we've broken it apart as far as we possibly can. So from there, let's go on to example number 2. So as we take a look at this one, we again look for a common factor before we do anything, before we do any grouping. There's nothing that will go into all four terms, no GCF. So we group the first two and we group the last two. Now notice, this is positive, positive. This one's negative, negative. So when I take a number out of this second one, I'm going to need to take a negative number out so that these two things can match. So when I start, I'm going to take out common factor here. There's no numbers in common, but there is a variable in common, x. I look for the highest power that will go into both of them. 2 will go into both of them, so a 2 goes under here. When I simplify that, remember guys, I write my x squared out in front, and I subtract my exponents. I've got to use those exponent rules that we spent all that time doing before. So that's going to leave me x to the first, which is just x, plus the x squareds cancel out here, and all I'm left with is 5. Now, the common factor in this one is 4. That's the number that's the GCF. But I need these to both be positive like these two are. So I'm going to take out a negative 4. And when I take out a negative 4, I'm going to write it as minus 4. That's going to leave me negatives canceling, 4 canceling. The only thing that would be left is x. The negatives cancel here. That'll make this a plus. And 20 divided by 4 would be 5. Notice, again, the whole point of this is to get these two things to match, which we do. So, now that I've got that matching thing, I'm going to put that x plus 5 out in front, and what's left over goes in the other one, that x squared minus 4. Now, I will tell you that later on we'll be able to continue factoring this part a little bit. This is called a difference of perfect squares. We're not there yet. Don't panic. I just want you to know that this could continue to factor, and later on we'll learn how to do that. Okay, so on to the next one. So we're going to look for a common factor for all of these. Guys, you have to think through. You can tell they're all even, so you know at least 2 will go into all of them. There is something that will go into all 4 of these. We need to look for the biggest number that will go into all 4 of these. The way that you do that is you're going to go through here, and you're going to take the smallest number, 24, and start thinking about the multiples of 24. 1 and 24. 2 and 12, 3 and 8, 4 and 6. So 24 will not go into 60, so that one's out. 12 will not go into 90, so that one's out. 8 will not go into 90, so that one's out. 6 might work. 6 goes into 60, 6 goes into 36, 6 goes into 90. Very cool. So 6 is the biggest number out of all the factors of 24 that will go into here. So that is your GCF for all 4 terms. Remember, if it's a GCF for all 4 of them, it's got to be done first. That GCF is going to go out in front, 6, and what's going to be left inside is going to be 4x to the third plus 10x squared plus 6x plus 15. All I'm doing is dividing every single one of these by 6 and simplifying them. Now that I've done that, I'm going to go back to doing the exact same thing I've been doing. I'm going to factor by grouping, by separating it into 2 groups. I'm going to keep that 6 out in front. And then I'm going to look for a GCF between these two. 4 and 10 will both divide by 2. They have an x in common. And the highest power that will go into both of them is a 2. So my GCF is 2x squared. And what that will leave me, and don't panic over the double parentheses. You're going to have parentheses. You just have to get used to it. 4 divided by 2 would leave you 2, and then for the x's, you'd have x to the first left over, so it's just x, plus the x squareds cancel here, and 10 divided by 2 would leave you 5. You do the same thing for this pair. The common factor would be 3. That's the biggest thing that'll go into 6 and 15. You're looking for that GCF. Since it's positive, we write plus 3. Guys, you cannot just put 3 there. It's not multiplication. It's plus 3. Then it's going to be 6 divided by 3 is 2x plus 15 divided by 3 is 5. Now, guys, you see that they match. That's the whole point. You see that they match. Here they are. They are here and here. Okay? But we have this extra parentheses here separating that GCF out in front. We need an extra parentheses back here in the back to close that out. That 6 is going to stay out in front. Then we write our common factor. What we're writing is the one in green. That's the common thing, the 2x plus 5. What's going to be left over for the other parentheses? Everything that has not gone in a parentheses yet. So that's going to be your 2x squared and your plus 3. That is a completely factored problem. So from there, we've got a couple more to keep practicing that. Let's go through and keep working on this, see if we can master this process. So for the next one, when we factor this one, guys, it's 5 and 15, 5 and 15. You can see that all of those will divide by 5. So we're going to take and we're going to divide everything by 5 to start off with. That's going to give us a GCF that goes in front of the whole thing. That's going to stay there the whole time, that 5. What that's going to leave me is x to the third plus 15 divided by 5 is going to be 3x squared minus, 5's cancel and I get x minus 15 divided by 5 is going to be 3. I'm going to need to factor by grouping, so I'm going to do the same thing I've been doing. I'm going to group the first two together and the last two together. I'm going to keep my 5 out in front. Guys, you can't let it float away. Keep that 5 out in front. We're going to have a GCF between these two. They don't have any numbers in common other than 1, and that's not one we write down. We've talked about that before. But what we do have is a variable, x, and the highest power common to both of them out of 2 and 3 is going to be 2. So we put that x squared out in front. That's going to leave us, if we divide this, we subtract the exponents, that's going to leave us x to the first, which is just x, plus the x squareds cancel here, and we're left with just 3. Now guys, this one's positive, positive, this one's negative, negative. The only thing they have in common is taking that negative out. So when I take out a common factor here, I'm going to be taking out a negative 1. I have to make these match this x plus 3. They're both positive. So I have to find a way to make that negative come out of there. To do that, I divide this by negative 1. What that leaves me is the negatives canceling, and that would leave me x plus 3. Remember, though, that I need an extra parentheses to close out that original one to go right there. You can see that I now have matching factors here and here. I'm going to take and keep my 5 out in front like I have every time. Guys, once I write it out here, it's got to stay out here. And then that's going to give me my common factor of x plus 3. And what's going to be left over for the other one is going to be x squared minus 1. Now, again, this is called a difference of perfect squares, and eventually we will learn to keep going with this. But for now, all we're worried about is the factoring by grouping, so we're going to stop at that spot. How do you know to stop? Because there's nothing else that we know how to factor at this point. So we have one more. Let's take a look at it. Now this one's very different in what it has in it, so make sure that you look very carefully when you think about a GCF on this one. GCF is going to be really important on this one. So the smallest number is 4. 4 will go into 8, 12, and 24, so the number part of the GCF is not bad. It's 4. But in this case, not only is there a number that will go into all of them, but there's also a variable that's come into all four of them. They can all divide by x. Now the highest power that will go into all of them would just be an x by itself. So we take that 4x, we write it out in front. Guys, you can't let it float away. But for all four of them, it has to go out in front. We take and we cancel out the 4. That leaves us x to the third minus 8 divided by 4 would be 2, x to the second, plus 12 divided by 4 would be 3x, because 2 minus 1 will leave you x to the first, minus 24 divided by 4 would be 6, and the x's cancel out completely. We now need to factor by grouping because there's nothing else that's common to all four of them. So we separate the first two and the last two. Keeping that 4x out in front, we look for a common factor between these. There's no number in common, but we do have a variable in common. The highest power that we have in common on that variable is x squared. That x squared is going to go in front. What's going to be left over is going to be just x minus 2 For the next one, we're looking for a GCF between these, and the number that will go into both of these is a 3. Guys, remember, since it's positive 3, you write plus 3. What that's going to leave me is x minus 6 divided by 3 would be 2. And I need that extra parentheses to close out for the GCF up here. I have that common factor here and here. That's what I'm looking for. So I can factor it out. I'm going to put the 4x out in front. What's in common goes next, the x minus 2. And then what's left over, whatever's not in a parentheses, goes in the last parentheses. So in this case, that'd be x squared plus 3. And that is a completely factored problem. I can't break anything else down, so I'm done. Now guys, don't multiply it back together, because if you multiply it back together, you're going to end up right back here at the problem where we started. So that is where you stop. Your whole point is to take it apart, not to put it back together. That was the last half of the chapter. We put it all together. Now we're taking it all apart. So, make sure you get these notes done, and we will not have an assignment on this until the next time that we meet. I'll see y'all next time.